Well, hello everyone. My name is Daniel Stange. I'm going to guide you a bit into the what we call the order of execution. If you're really a master in that topic, it's probably a bit too shallow in 20 minutes, so you won't get much insights in here. So if you feel really deep into the order of execution already, it's probably a good idea to just consider looking something more exciting than me diving just over the order of execution. But we'll see. I'm happy if you stay and get the whole picture that I'm going to present. I'm a user group leader in Frankfurt, Germany. I'm 20 times Salesforce certified, member of the community groups advisory board, blah, 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 a lot of that. And I happen to be the author of a new Pluralsight course on exactly that topic, and I give you the abridged version of what I'm worked through with Don Robbins in that course. So what we're going to do is have a short introduction what the order of execution actually is, so that we are on the same page. And I'll show you some order of execution related phenomena in practice. It's just one short demo. And after that, I'll show you why the thing that looks funny in the demo is actually deeply relevant for your implementation practice. We'll go through the order of execution in depth for sure, because that's something you don't see really in visuals typically. And I'll guide you a bit into mitigation of typical risks and issues that you're going to have. So, but first off, who's actually, who knows the term order of execution, knows what it is and how knows it feels? Anyone deeply involved into the order of execution? None? Who's completely new to the topic? Oh, okay, so we're just in the middle of that. Have you ever seen any order of execution related problems in your orgs? Yes? What kind of problems are these?
Versus validation rules that conflict.
Yeah, okay. I was looking more for, in terms of into the types of clusters of issues you have there. What is the typical issue there? DMLs, Socal limit consumption, CPU time consumption. CPU time being the worst of all of these, because you cannot really catch the CPU time consumption. So, just as a primer, the order of execution is actually the sequence of events that are going to happen after you manipulated a record. Manipulate a record is insert, update, delete, undelete. Whenever you interact with the database, there's a sequence of things that are going to happen. And they are in a distinct order, and this order is the safe order of execution. The order of execution relates to the sequence of metadata types that follow each other. So it's, for example, validation rules before workflow rules, but it is not the executed units. So you cannot tell if this workflow rule is executed before the other workflow rule. It's not even random. If in the test that we ran, and we tested about 200,000, 300,000 records, the order is always the same, but not predictable. So the workflow rules always ran in the same order, but who knows? It's not the order of the ID, we checked. It's not the order of the names. In each org, it was different, but it was a distinct order per org. You cannot trust on that. And the order of execution doesn't tell you anything about it. So the scenario that I have is, there's an old door that I found in the house, and this door should be painted. And you know, if you want to paint a door, and it was red once, it should be painted black, right? For the ones in pop culture for you. So I chose each Salesforce mascot to do its own job. Sassy, for sure, the oldest one, uses workflow rules and paints the door in red. Because it's the old door, it's red. And Process Builder paints it black, because he wants it painted black. And Cody, the fellow, the jolly bear, paints it blue with a before insert and before update trigger. They all update the same field. They paint the field, literally. And I have a counter there that counts the numbers of iterations. And I have a work log where every one of these guys just logs the work he did. So, and I'm not a big Rolling Stones fan, so I don't want the door to be painted black. So I created a validation rule to prevent Astro to ever paint the door black. That's important because I don't want the door painted black. It's just nasty. So, first question for you. What color is the door now after I ran the automations? Do you have an idea what the color is? Correct. Blue is the correct answer, but we'll see later why. And, whoops, I'm sorry. Let me go back to another one. How many layers of paint will be on the door after just one paint job? No, it's not 2. It's not 1, it's not 3. 4 is not correct.
0.
6 is a bit closer. You get to in the rhythm. It's still more. It's still more. Okay, I'll show you in a minute. Let's go into the demo. You won't get. You obviously don't get to the point. So, I created a quick action here to paint the door again, so that I don't have to recreate the record. You have to trust me that. Whoops! I have to stop the presentation then. There we are. So, we can create a new door as well. I used the quick action first to paint the 20th door in a new way. So let's fire this off. The record has been updated. And what happened is the number of paint jobs is 15. Because I allowed the process builder to be re-evaluated after it changed the field. I also allowed the workflow rules to be re-evaluated after it changed the fields. But you see, there's only one red entry there. There's a rule to it in the order of execution. And you see all the blue paint jobs done by the triggers. And if you want to go in detail here, you can set the log levels to profiling. And you get that fancy, that's the analysis perspective of the developer console. You get that fancy ping pong, and you see what's happening actually. That's the analysis perspective of the developer console, and it's only available if you set any of the, at least the profiling option to finest. And what you also see is it consumes a lot of time, almost 5 seconds, out of which 230 milliseconds are consumption of CPU time. That's for one record, one save. 5 seconds actual time, 230 milliseconds consumed of the CPU time. And you see how this gets relevant here. I'm a PowerPoint master. I didn't restart the presentation at the correct spot. So the door is blue. The executed units are 15. You see the lines of the mascots in the order that they run. Cersei being really out of the game, but the other ones ping-ponged back and forth. It's a fun exercise, actually, but it really means a lot because you should know about the order of execution because it affects the predictability and the consistency of how your app behaves. And it affects performance. You saw one record, 5 seconds. That's a long time, actually, to wait for a record to change. And with limit consumption comes defects that affect the robustness of the process. And I'll show you how this actually works. This is everything that happens in a save cycle. Loads and loads of stuff. And it gets even worse if I show you that there we are. There's the magnifying glasses. It starts all here with the DML operation to start, and then the triggers sit at the very beginning of the process, and it goes all the way around. Here's the first writing to the database before the after triggers run, and it goes all the way around to workflow rules and process builder. That's the first step that I want to look closer in. Because whenever you change something in workflow rules and process builder, they will go force the operation in another cycle of triggers. That's where the sequence of process builder, trigger comes from. So that's the exit Cersei took. and then it went into process builder, and then it went round and round and round and round for 6 times. Workflow rules and process builder can run as often as 6 times in one operation, but each workflow rule won't fire again once it had been fired, even though it listens on a field change of the exact field. And what you don't know, what I didn't talk about just now, is triggers can run up to 16 times, but we never get to 16 in that course of operations. But 16 times is also the depth of a trigger operation. If you happen to reload the record in the after trigger, just to manipulate it again, you spin a child of the same trigger and have a re-entrance in the same trigger in another instance. This can be 16 times deep, so a grandchild of a grandchild of a grandchild of the operation eventually. This is terrible, and it will eventually end in a trigger death, maximum execution death reached. That's what happens. But this can happen. If you ever have to reload the record in an after update trigger, you have to make sure that this is the last time you enter the after trigger with a recursion flag, for example. If you ever re-enter the after trigger twice on the same record, it will kill you in terms of the 16 levels of trigger death on the same trigger. And there's another fire here. Fire means danger, danger, danger. That's roll-up summaries and cross-object workflow rules. These inject their parents, or the affected parents and grandparents, into another full safe cycle. And there's one tool that can do a lot, that's Process Builder. It can update child records and parent records from the original operation. And again, safe cycles, full safe cycles for everyone. And full safe cycles for everyone, full safe cycles for free doesn't mean anything good on a Salesforce platform. A bit more of a background. The orange part is the database, is the safe cycle, and that's what we call the database transaction. The blue cycle represents the database transaction. And if there's triggers, there's an Apex transaction around it. Now, Apex transactions don't only start in triggers, they can start in code that lead to a database operation that invoke a trigger. So the more complex safe cycle in code is you do something, then you save the record to the database, then you go around the cycle, and if it completes, you do probably more Apex after that, which is in somehow a dangerous thing, because if anything fails during this cycle, not just in the orange cycle, not just in the blue cycle, if everything fails and throws an exception here, the whole process will be rolled back with very little exceptions. So you have to make sure that all of the limits that you consume last until you get here to get the record to the database. If any exception occurs and you don't catch that exception, you roll back. And a CPU side time limit exception cannot be caught because you cannot put Apex around code that already failed. Time's up, you cannot catch it. So that's important to know. The limits that you have don't have to last for just the blue cycle, but the purple cycle. And the purple planes, more or less, that you have left and right of the cycle. Now, most of you, when building applications, consider one record as a test. It's not a test, it's trying it out. A whole transaction can contain, each batch of a transaction can hold 200 records at maximum. That's the batches triggers typically do. And you have to plan for these 200 records. No way around it. Which leaves you with a minimum of limits already, if you break it down. 10,000 milliseconds break down to 50 milliseconds each. Remember the number we had at the beginning, 230? This operation will not work for 200 records in a row. So as soon as you do a data upload, it will break. But it had recursions, and not just one, but 7. So what I wrote out here is the split of the limit consumption for 1 and 2 recursions caused by one workflow or process builder field update, or workflow and process builder field updates. It's just 2 recursions. We saw 7 in the process we saw. And already it leaves you only with 60 milliseconds per record as processing time for that operation, which is really terrible. And if you consider that you can if this happens, only pull 66 lines, rows from the database and return 16, your headroom to operate with the database is quite small, getting small, and it flies away the more recursions you have. So as a mitigation, the thing you have to do is work with as few automations on each object as possible, because when you start workflow rules on an object that has already a trigger or more than a trigger, it will inadvertently cause recursions as soon as it does workflow field upgrades. So you have to look at recursion control in the trigger, which is an extremely hard to handle topic, because what do you do with partial content, for example? If someone says, oh, I don't mind if all records go through, let's go with the all or none flag as set to false. How do you handle recursion for that? Some get rolled back, some go into the database. The state is unclean, more or less. You have to handle this. So go for as few automations as possible on the same objects, even if it's at a price that you don't build with Process Builder on triggered objects. That's the price you have to pay in enterprise building for that. The next thing is, whenever you do, you have to go that way, try to filter as effectively as possible, because if you're specific about what you're going to do, it will save you from getting side effects. One thing that's really important is also to avoid checking these two fellas, if possible. They're hidden away from your control most of the time, especially in Process Builder, for good reason, because it's terribly dangerous to re-evaluate the same thing again and have a field update again. So in Process Builder, they're hidden away. Always remember before you check this box that they're hidden from you for really good reason. In workflow rules, it's a bit easier, but they can't refire on their own criteria. So you're pretty much safe after one entrance into the workflow rule. But really consider why you're doing this. It's really important because it causes side effects on the code side. And last but not least, there's one thing we try to do, that is keeping maps of what we're building. It can be in a charting software. It can be on paper. Just outline which objects you are using, which kind of automations you have there, and which kind of fields like roll-up summaries, cross-object workflow rules, etc. you're doing on that on this object, so that you know that an operation will spread out. If you update an opportunity line item, it will affect the opportunity because it calculates the summary of the amount. From the amount, it will cause an update to the account because it calculates the total revenue on the account. That's a built-in relation, and this is true for all the custom objects you build as well. So know these kinds of relations, because when you do something on the account, on the opportunity line item, it will roll up and spread out. It's like a nuke that you have in your org if you don't consider this relation. With that, how did I find and learn about it? There's only one page in the whole documentation on the order of execution that really outlines what it is, and it's hidden in the official developer documentation. So you as an admin, do you look into the developer documentation? That's not your resource, from how I feel. It's nothing on Trailet, nothing for admin geared in particular to admins, and there is no visuals that are supplied by Salesforce. So a lot of people in the community did this work to map out the operations. I did as well. You saw these in my slides. And if you want to see this in action and have the discussion on that, you please check my new Pluralsight course. Pluralsight is a paid service, but you can get it for free for 30 days if you go through Don Robbins' lead collection. Just follow that bit.ly. Don will provide you 30 days of free access if you're not a user yet. Side note, if you have a Gmail account and you are already registered to Pluralsight, you can do the plus label to register again. Don doesn't mind. Pluralsight wants him to register the people personally, so you could use people could use email labels to get a second time of free access to that. With that, I'm open to your questions. Thank you for your attendance. The demo I showed is on GitHub in this repo. And feel free to connect with me on Twitter. I'm happy to get 1,000 followers before Dreamforce. So 907 is the count. If all of you connect with me, it's 911 or so, because most of you are already in there. So with that, thank you. I'm open for your questions, either here or outside. I'd prefer to have the questions in public so that everyone can learn from your questions. So don't be shy. Bring your questions. And thank you. If not, you're free to go. Oh, there's one. There's one.
On the slide, you say that if it's possible, it's a good idea to practice to use only one tool for automation. And now you know there are things like lightning flow, and it's not necessary. You don't have to use on a page. You can use flow and a page. So how can really use just one automation tools?
It's not. The question is how do you actually handle this, and how do you work with the situations that are not just only. It will happen that there are more than one automation tool on one record. So how do we handle this? There's only one answer to that, and it's not really satisfying. You have to look into what you're doing, and you have to be aware of that situation. That's all you can do. You can try to build it as much to performance as possible. So, for example, avoid recursion if not necessary. But there are probably recursions necessary at all. Oh, I didn't tell you about the custom validation that I brought in, right? Did you see the custom validation go up? No, you didn't, because the custom validation doesn't run after the process builder, but before. So the update of the process builder will never see the custom validation again, not even on recursion. So that's, I just remembered this because what you ask is actually something that is important. If I want to validate that even a trigger cannot, even in a workflow or an automated update, the record can never be this and that. It can only work with triggers. Process builder workflow rules never see the custom validation again. It only has the system validations, and system validations will only check for, is the name null? Because you always have a name. It's really, you have to take your precautions, probably map your automations properly, test your automations properly, test at scale, and make sure that you know what's happening. Knowing is the first key to actually be able to manage it. If the situation cannot be avoided in most of the orgs I see, it's just there. If you don't want to build everything again in code, deal with it. So that's, I told you the answer is rather unsatisfying, but it's the truth. You just have to know what's around and try to build your way around it as good as possible if you don't want to refactor everything. If you want to be on the safe side, you have to touch this thing again and prototype in process builder, build again in code, or remove the code and put everything into process builder and flow. That's a way to do it as well. You don't have to stick with code.
Couldn't we envision a functionality where if you configure something in process builder, somebody cleverly creates something that automatically generates code, which you can then review and integrate into
that's a good design. The question is, couldn't we build process builder just in a way that it auto creates code that we could review and then put into production? That's actually a clever idea, and more or less that's what the process engine does. Nonetheless, it always compiles. If you remember the limits on the formula, it's not characters of the formula, but the characters of the compiled size of the formula. So all the automations tool compile into whatever language is behind. And so that actually happens under the hood. You just don't see it. That would be fun, actually, to have kind of unified platform, and you have just decide which UI you're using. Is it the code UI? Is it the click and design UI? Probably not process builder any longer, probably rather just flow. That would be nice to have. It's probably something you have to talk to Shannon Hale about to steer her in this direction and get her build it. Okay, so that's, I think we're almost done. Thank you for coming. Have fun.